Hello viewers, in today's class we are going to discuss an important and conceptual problem from limits, right? And here what we have to do, we have to find the left hand limit and the right hand limit of this function, that is f of x is equal to x plus 2 divided by greatest integer of x minus 2 when x tends to minus 1. Right, so here we'll test whether the limit of this function when x tends to minus 1 exists or not, right? And for this we have to separately calculate the left hand limit and the right hand limit of this function when x tends to minus 1, right? So let us start. So now viewers, let us first calculate the left hand limit of this function, right? So for the left hand limit, the notation is the limit x tends to minus 1, and here we'll put a negative sign, and this negative sign indicates that we are finding out the left hand limit, right? And here we'll write f of x. Clear? Okay. So now we can write limit x tends to minus 1, and here we'll again we'll write minus 1, and for f of x we can write x plus 2 divided by greatest integer of x minus 2, right? Okay, so now here what we will do, we'll take x is equal to minus 1 minus h, right? So we'll introduce the quantity h, and h is greater than 0, right? H greater than 0 implies that h is a very small quantity, but it is always greater than 0 but less than 1, right? So when x tends to minus 1, obviously h tends to 0, right? So now replacing here x by minus 1 minus h, right? So we'll have the left hand limit as the limit h tends to 0, and for x we can write minus 1 minus h plus 2 divided by greatest integer of x minus 2. So for x we can write minus 1 minus h minus 2, right? So now we can simplify this expression. So the left hand limit is now equal to limit h tends to 0, and here we'll have 2 minus 1 is 1, so we'll have 1 minus h, and in the denominator we have minus 3 minus h, right? So here we'll have greatest integer of minus 3 minus h, right? So viewers, now in the next step we are not going to directly substitute h is equal to 0, but what we will do, see, h is a positive quantity because h is greater than 0, but it is always less than 1, right? So h lies between 0 and 1. So let us multiply throughout by minus 1, right? So if we multiply throughout by minus 1, what we will get, we'll have 0, here we'll have minus h, and here we'll have minus 1, right? But the direction of the these inequalities will get reversed, so here we'll have these directions, right? So we can write minus 1 is less than minus h, and that is less than 0, right? So what we have done here, see, h lies between 0 and 1, multiplying throughout by minus 1, we'll have this inequality. The sign of or the direction of the inequalities get reversed here, so now we can write this inequality like this, right? And now if we add minus 3 throughout, what we will get, see, minus 3 minus 1, here we'll have minus 3 minus h, and here we'll have minus 3 plus 0, right? So we'll add negative 3 throughout this inequality, so we'll have minus 4 here, and here we have minus 3 minus h, and here we'll have minus 3, right? So now see, minus 3 minus h, it lies between minus 4 and minus 3, clear? So here we'll have minus 4, and here we'll have say minus 3. So minus 3 minus h, it lies between minus 4 and minus 3. So therefore by definition of greatest integer function, the value of greatest integer of minus 3 minus h is always equal to minus 4, right? So we'll now take this minus 4 over here. So now the left hand limit, it becomes limit h tends to 0, and we have 1 minus h over minus 4, and now we can take h is equal to 0 over here. So we'll have 1 minus 0 over minus 4, that is minus 1 over 4, right? So the left hand limit of this function when x tends to minus 1 is minus 1 over 4. So here we can write the left hand limit, that is minus 1 over 4, right? So now let us calculate the right hand limit. So now for the right hand limit, we have the notation limit x tends to minus 1, and here we'll put a positive sign which indicates that we are going to find out the right hand limit of the function f of x, right? So now we can write limit, this is x tends to minus 1 plus, and for f of x we can write x plus 2 over greatest integer of x minus 2, right? So now we'll put x is equal to minus 1 plus h, right? So we'll take x is equal to minus 1 plus h, where h is greater than 0 and h is a very, very small quantity, and when x tends to minus 1, obviously h tends to 0, right? So we'll now replace here x by minus 1 plus h. So right hand limit, it we can write it like this, limit h tends to 0. For x we can write minus 1 plus h, here we have plus 2, and now we have greatest integer of x minus 2. For x we can write minus 1 plus h, and here we'll have minus 2, right? So now we can simplify it. So limit h tends to 0, here we have 2 minus 1 is 1, so we have 1 plus h, and here we have greatest integer of minus 3 plus h, right? Okay, so now we'll adopt the same method to assign the value to this quantity, that is greatest integer of minus 3 plus h. So see, h lies between 0 and 1, right? So h is a very small quantity, but it lies between 0 and 1. So now what we will do, we'll add minus 3 throughout this inequality, because we want to find the quantity minus 3 plus h, right? So we'll add minus 3. So here we'll have minus 3 plus 0, we have minus 3 plus h, and we have here minus 3 plus 1, right? So this is minus 3, here we have minus 3 plus h, and here we have minus 2, right? So now this inequality, this shows that minus 3 plus h, it lies between minus 3 and minus 2. And from the definition of greatest integer function, the value of greatest integer of minus 3 plus h is always equal to minus 3, right? Because if this value, that is minus 3 plus h, it lies between minus 3 and minus 2, then the value of greatest integer of minus 3 plus h is equal to minus 3, right? So here we'll write minus 3. So we have limit h tends to 0, and we have 1 plus h over minus 3, and now we can take h is equal to 0 over here. So we have 1 plus 0 over minus 3, and that is equal to 1 over minus 3. So viewers, the right hand limit of this function is equal to 1 over minus 1 over 3, and we see that the left hand limit is not equal to the right hand limit, that is minus 4 is not equal to minus 1 over 3, and therefore we conclude that the limit of this function, that is f of x, when x tends to minus 1, this does not exist, right? So this is how we solve this type of problems in limits.